So now one more important aspect. If laser heat source is moving, it can move in any path. Again, user will decide what kind of scanning path he wants. The most famous is definitely a straight or linear path. But again, mathematically also and even practically also, sometimes it is feasible or required to move your laser in a certain path. Let's say I have shown here sinusoidal path. Someone may say, can we move, let's say, like a cycloidal path, or let's say elliptical path like this? Yes, possible. And even in the same subroutine, it is possible. Again, you need to change your equations and just customize your subroutine. As for linear path, it is very straightforward, because as I shown here coordinate system, you can see here the x is along the scanning path. So our laser have only one velocity, that is v, here along the x direction. So only x coordinate will update according to velocity, and the t is showing time definitely. So after 1 second, what will be the x coordinate? That is depend on the velocity and time. Right? This is very simple 10th standard physics, that we can calculate distance by multiplying velocity into time. But let's say in the bottom figure, you can say laser is moving in the x direction, at the same time it is moving in y direction also. So both coordinates are changing simultaneously, and they are function of each other. Simultaneously, when the laser is moving in the x direction, it is fluctuating or oscillating sinusoidal, right, in the y direction. So that's why you can see, whenever I am writing equation for y, there is x here available. So x velocity is same, v times t, x coordinate, but the y coordinate is a cosine or sine. That is not different, because sine is basically, if I am say sine wave, it will start like this. If I will say cosine wave, it will start like this. The equations, there is phase difference, nothing else. So we can call it a sinusoidal or cosine wave, whatever. So while moving in the x direction, it is also oscillating as a sinusoidal path. So that function I can insert in the subroutine. So whenever I am saying sinusoidal, the most important two things one can ask: how I can enter amplitude, and the wavelength. Again, this is very simple mathematics, trigonometry. You know what is the wavelength of the sinusoidal wave and what is the amplitude. So both of these parameters are user parameters, one can define. Let's say here A is amplitude, lambda is the wavelength, and sometimes wavelength is not directly known. We know, let's say, speed and frequency. From that also V equal to n lambda or f lambda. In that way also we can calculate, and we can directly put that value in the subroutine. So just two examples I have shown here, but such many paths one can think, one can actually experiment on it. So I am actually providing you one research direction. So in my study, I focused on, let's say, two laser paths, straight and sinusoidal. I got different benefits of both of them. One can really go in this direction. Let's say, what will happen if I will move in ellipsoid direction, what will happen? So one can go in that direction and check. So this course is not only for, let's say, engineering student or postgraduate or PhDs, postdoc. It will cover a range of researchers and learners. That's why I used earlier word modeling. So your thought process should be developed in that way. So think on each slide how I am developing the equations, and lastly I will show where this will fit in the subroutine. So the whole dots will be connected, and finally we'll have a very good user subroutine that you can customize at any point for your own interest, so that you can create your new understanding, new research. So from basic understanding to research publication, this course will help you.